Factorising is the opposite of expanding. When we expand an expression, we multiply every term inside the brackets by the term attached to the outside. And we end up with an algebraic expression that looks like this. If factorising is the opposite, and we know that the opposite to multiplying is to divide an expression, then this tells us that to factorise any given algebraic expression, it requires us to find the highest common factor of every term in that expression. And essentially what we're doing is putting that expression back inside the brackets. So let's have a look at example 1. We need to factorise the expression 12 plus 4x. So we know that this requires us to find the highest common factor between 12 and 4x. So we need to think about what will divide both of those terms evenly. We know they both divide by 2. They also divide by 4. But the highest of those two terms is 4, so that will be our highest common factor. We'll start by writing that outside a set of brackets. So once we identify the highest common factor, it's the term that's attached to the outside of the brackets. What we now need to do is figure out what the remainder is when I divide both of those terms by that highest common factor. So 12 divided by 4 leaves me with 3. So the first term that needs to go inside my set of brackets is a 3. 4x divided by 4 leaves me with x. So the next term that needs to go inside my set of brackets is an x. Because it's a positive x, I also need to separate those two terms with a positive. So my final answer when I factorise that expression and put it back inside the brackets is 4 outside of 3 plus x. And you can check that you've done it right, because if you expand that expression, you should get back your original question, which we do. Now let's have a look at an example where our highest common factor is not a numerical value, but a letter. Looking at the two terms in front of us, we're trying to find the highest common factor between 9x and x squared. They both divide by x, and so that will be our highest common factor, and we'll write that outside the set of brackets. Now we need to divide both terms, 9x and x squared, by x. So 9x divided by x, we know from our algebraic laws, leaves us with 9 as the x's both cancel. And x squared divided by x cancels down to leave us with just one x. So they're the two terms I'm going to write inside my brackets. This time, however, I had a negative in between my two terms, which meant that x squared was a negative x squared, leaving me with a negative x, and so I need to make sure it's a negative x inside the brackets. And that's my factorised expression. Let's have a look at example 3. This time my highest common factor contains both a letter and a number. So both 5m and 10m squared divide by 5m. So that's the term that I will write outside the brackets. Now dividing both my terms by that highest common factor, 5m divided by 5m, well that cancels down completely and leaves me with just one whole. And 10m squared, well that's a positive 10m squared, divided by 5m, that cancels down to leave me with 2m. So when I write those inside the brackets, both my terms are positive, and that's my factorised expression. The last example we'll have a look at is when we can actually pull out a negative highest common factor. So both of these terms will divide by negative 3. So I'm going to take the negative outside the brackets and see what I have left over. Now I need to divide both negative 9 and negative 3a by negative 3. Now we need to remember that two negatives here are going to cancel out to give us back a positive number. So negative 9 divided by negative 3 gives me back positive 3. And negative 3a divided by negative 3 gives me back positive a. So both the terms inside my brackets will be positive terms. And again, you can double check your answers correct by making sure that when you expand this expression, you get this back as your answer. So I'm going to leave you with one final question. Do you think that you can factorise any number of terms given? Not just 2, but say 3 or 4. And how would you go about doing so?